Hello, curious minds. Imagine a star so powerful that it can burst into brilliance, outshining entire constellations, and then fade back into darkness, only to repeat this cycle every few decades. This is the story of T Coronae Borealis, a star that has puzzled astronomers for over a century. T Coronae Borealis, or TCRB for short, isn't just any star. It's a stellar chameleon, a master of disguise in the cosmic theater. You see, most stars live relatively predictable lives, steadily burning their fuel over billions of years. But TCRB? It's a rebel that refuses to play by the rules. This star belongs to a rare class known as recurrent novae. Now, a nova is a sudden, dramatic brightening of a star, not to be confused with a supernova, which is the explosive death of a star. TCRB is a recurrent nova, meaning it undergoes these spectacular eruptions over and over again, like a cosmic volcano erupting into a blaze of glory. What makes TCRB even more fascinating is its unpredictable nature. Unlike some astronomical events that we can predict with remarkable accuracy, the outbursts of TCRB are shrouded in a veil of mystery. We know they occur, but pinning down the exact timing is a challenge that keeps astronomers on their toes. Now let's delve deeper into the heart of this stellar drama. T Coronae Borealis isn't a solo act, it's part of a cosmic duo, a binary star system locked in a gravitational embrace with another star. That's TCRB and its companion, a red giant star. Now, red giants are stars in their twilight years, having exhausted much of their nuclear fuel. They've swollen up to enormous sizes, engulfing anything that dares to venture too close. And in the case of TCRB, its companion's bloated atmosphere acts like a cosmic buffet. You see, TCRB, unlike its giant companion, is a white dwarf star, the dense remnant of a sun-like star that has shed its outer layers. White dwarfs are incredibly hot and compact, with gravity so intense that a teaspoonful would weigh tons on Earth. As the white dwarf in TCRB pulls material from its red giant companion, this stolen hydrogen forms a swirling disk of gas, known as an accretion disk, around the white dwarf. This accretion disk is where the real action happens. So, let's talk about how it works. The white dwarf is incredibly dense, with gravity so strong it could crush atoms, but it's not dead yet. Orbiting close by is a red giant, a star in its twilight years, swollen and shedding its outer layers like a cosmic confetti. This is where the story of T Coronae Borealis, a recurrent nova, unfolds. The white dwarf, with its insatiable hunger for matter, pulls material, mostly hydrogen, from its puffed-up companion. This stolen gas doesn't fall directly onto the white dwarf's surface. Instead, it spirals inward, forming a swirling disk of gas around the white dwarf known as an accretion disk. Think of it like water swirling down a drain, but on a much grander scale, heated to millions of degrees by friction and the white dwarf's intense radiation. As more and more hydrogen piles onto this disk, the pressure and temperature at its base increase dramatically. This buildup continues until suddenly, a spark ignites the inferno. The intense pressure at the bottom of the accretion disk triggers a runaway thermonuclear reaction. It's like billions of hydrogen bombs detonating simultaneously. But instead of destruction, it creates a brilliant outburst of light. This is the nova we observe from Earth, a sudden brightening of the star system, sometimes visible to the naked eye. But here's the catch with recurrent novae like T Coronae Borealis. The explosion isn't strong enough to destroy either star. Now, let's take a trip down memory lane to revisit some of T Coronae Borealis's most notable performances. Astronomers have been observing TCRB for centuries, and its history is peppered with these dramatic outbursts. The first recorded sighting of the TCRB nova was in autumn 1217. A man named Burchard, abbot of Erzberg, noted his observance of a faint star that for a time shone with great light. Now let's go forward in time. One of the most spectacular eruptions occurred in 1866, when TCRB suddenly flared in brilliance, becoming easily visible to the naked eye. Imagine the astonishment of skywatchers back then. For a brief period, TCRB became one of the brightest stars in the constellation Coronae Borealis, outshining its neighbors. Then, just as abruptly as it brightened, TCRB faded back into relative obscurity, leaving astronomers eager to understand the cause of this stellar outburst. Another notable eruption occurred in 1946. This time, advancements in telescopes and astronomical instruments allowed for more detailed observations of the event. Scientists were able to study the light emitted by TCRB during its outburst, revealing valuable clues about the composition of the material ejected during the nova. Now, for the moment you've all been waiting for, The prediction that has astronomers and skywatchers alike buzzing with anticipation, the possibility of T Coronae Borealis gracing us with another one of its spectacular shows in the very near future. Based on observations and models of TCRB's past behavior, some astronomers believe that the star is due for another outburst. And the most exciting part, this prediction falls within our lifetimes. In fact, a significant clue emerged in spring 2023 when astronomers observed a noticeable dip in brightness from TCRB, known as a pre-eruption dip. This dip is thought to be caused by the buildup of material on the white dwarf, signaling that an explosion could be imminent. While predicting the exact timing of these events is notoriously tricky, some models suggest that TCRB could erupt again as early as this year. If the pattern continues, some researchers say, the nova event could occur by September 2024, and it will be visible to the naked eye for a little less than a week. Now, are you ready to embark on a cosmic treasure hunt to find T Coronae Borealis for yourselves? Don't worry, you won't need a fancy telescope to spot this celestial wonder. With a little guidance and a clear night sky, you too can witness the majesty of this recurrent nova. T Coronae Borealis is located in the constellation Coronae Borealis, which is Latin for Northern Crown. This constellation is relatively easy to find in the northern hemisphere during the summer months. To locate Coronae Borealis, start by finding the Big Dipper, one of the most recognizable star patterns in the northern hemisphere sky. Follow the arc of the Big Dipper's handle away from the dipper itself, and it will lead you to a bright orange star called Arcturus in the constellation Bootes. Continue along that same arc, and you'll stumble upon a semicircular pattern of stars, resembling a horseshoe or a tiara. That's Coronae Borealis. T Coronae Borealis is located within this crown-shaped constellation, but remember, it's not always visible to the naked eye. Now let's step into the shoes of astronomers and explore the cutting-edge research and observations that are helping us unravel the secrets of T Coronae Borealis. Astronomers have been meticulously observing TCRB for decades, using a variety of telescopes and instruments to study its behavior in detail. Ground-based telescopes equipped with specialized spectrographs allow astronomers to analyze the light emitted by TCRB, revealing its chemical composition, temperature, and velocity. By studying the spectrum of light, scientists can identify the elements present in the star's atmosphere and the material ejected during its outbursts. Space-based telescopes, such as the Hubble Space Telescope and the Chandra X-ray Observatory, provide a different perspective, allowing astronomers to observe TCRB in wavelengths of light that are blocked by Earth's atmosphere. Hubble's sharp vision has captured stunning images of TCRB and its surrounding environment, revealing the intricate details of its binary companion and the ejected material from previous outbursts. Chandra, on the other hand, observes the universe in X-rays, which are emitted by extremely hot objects such as the accretion disk around TCRB's white dwarf. These X-ray observations provide insights into the energetic processes occurring close to the white dwarf, where the material from the red giant is being pulled in and heated to millions of degrees. You might be wondering why all this fuss over a single star system. What makes T Coronae Borealis so special, so captivating to astronomers and space enthusiasts alike? Well, the answer lies in the profound implications that studying TCRB has for our understanding of the cosmos. First and foremost, TCRB serves as a cosmic laboratory, providing us with a unique opportunity to study the physics of accretion disks, thermonuclear explosions, and the evolution of binary star systems. These processes are fundamental to our understanding of how stars live, die, and interact with their environments. By studying TCRB, we're not just learning about one peculiar star system, we're gaining insights into the fundamental processes that govern the evolution of countless stars throughout the universe. Moreover, TCRB plays a crucial role in enriching the interstellar medium, the vast space between stars with heavier elements. During its nova outbursts, TCRB ejects material that has been enriched with elements like carbon, nitrogen, and oxygen, forged in the intense heat of the thermonuclear reactions. These elements are essential building blocks for planets, life, and everything we see around us. In a sense, we owe our very existence to stars like TCRB, which have seeded the cosmos with the ingredients necessary for life to arise. As we conclude our exploration of T Coronae Borealis, we're left with a sense of awe and wonder at the sheer power and beauty of the cosmos. But this journey doesn't end here. T Coronae Borealis continues to captivate astronomers and space enthusiasts alike, and there's still much more to learn about this enigmatic star system. Future observations with even more powerful telescopes promise to reveal even greater details about TCRB's behavior. Thanks for joining me on this journey through the cosmos and the incredible story of T Coronae Borealis. What other space events are you excited for? Share your thoughts in the comments below, and don't forget to like, share, and subscribe for more exciting space adventures. Until next time, keep looking up.